Hi everyone, welcome to lecture number 12, finding intersection point in a Y-shaped linked list. So let me change my color, like I've used the same color previously. Let me change it to black. Okay, so let's see how a Y-shaped linked list looks like. So this is one node, this is one node, and this is another one, and now we have another thing like here, and we can simply have an attachment here. Okay, or we'll have further more nodes, so you'll get a better understanding. And let's say this one also. Okay, so now what you need to do is, so these are, it contains a Y-shaped thing, right? So there is a junction here. You just need to return this particular value. Okay, you just need to return this node. How you can solve this problem? So like there can be multiple approaches. So first I'll tell you the approach which comes to everyone's mind, right? It's easy, which is using map, right? Or sets. Like in Go we don't have sets, we only have maps. So we can use maps as sets. How? Let's say there is a value 3 in a set, and now you are trying to insert 3, which doesn't work, right? But if you consider a map also, let's say map consists of key 3 and value as true, and now even if you try to insert another key with 3 and true, will you be able to add a new node, like new key? No, right? So in Go we are going to use maps as sets. Okay, if you have any like still doubt in how we are using this, you can check out my blog, like basics of Go. So there you can see the basics of entire Go. You can learn from there. Even when I forgot something, I'll be looking at my previous blogs itself. Okay, so next let's see how we can solve this problem in approach 1, right? Approach 1. So now let me use another color. So now what I'll do is I'll keep a pointer here. Let's say this is head 1, and I'll point another pointer to head 2, right? So now I'll maintain two separate maps. So this map is map H, or to make it simple, I'll make just map M1, and this will have a map M2, right? This will track this, this will track this. So now first what we'll do is, we'll see one iteration, and from there it will be normal. And now first we'll insert this particular thing into this map. Okay, that means this is 1, let's say this is 2, this is 3, this is 4, this is 5, this is 6, and let's consider this is 7, this is 8, this is 9, this is 10. It's your wish, you can consider any names. Just for information I was trying this. So now, my bad, I'll be selecting this color. Okay, so now M1, now we'll insert 1, right? And for M2 we'll insert value 7. Oh, I'm unable to understand my own handwriting. Let's understand this as 7 and this as 1. Okay, so now after every insertion you will check whether this particular key, which is 1, is present in M2 or not. Okay, so let's say what you'll do initially is you'll simply map of M1, you'll add your current head and you'll make it as true. Same for M2, which will make H2 to true, and you'll check whether head 1 is present in M2, and in the same way you'll check H2 whether it's present in M1. Okay, if these are present, then that means you have found the junction, right? See, if you have H1 and you'll move here H2, this will become 2, this will become 3, this will become 4, and let's say this will be here, this will be here, and this will be here, until this reaches the end. Let's say it moves here and it knows that yes bro, this particular 4 is present in M2 when you're traversing your head 2, right? So that means, sorry, in M1, in map 1, because previous head is already traversed this loop, right? So now you can say that yes, this particular key is present in M1, so that means there is an intersection point between these two. In this way we can solve this problem, but if you see, there is an issue of order of n size complexity, simply space complexity, okay, and the time complexity stays order of n. The loop, you need to loop the entire linked list. So can we optimize this particular size? Yeah, which I said, either you should reduce space, either you should reduce time, or you should use a different algo, right? Yeah, so let's understand some basic principles so that you'll understand it better. Like you will see like, wow, there is some sort of this thing which we can use. Yeah, I just learned it, so I'm not bluffing anything. So this is also new to me. So let's see. Now let's say there is this thing, this particular thing, and this thing, and here this is simple, right? Let's say this is A, this is B, this is C, and this is D. Okay, so now let's say there is a head pointer here. Okay, so this is a head 1 and this is a head 2, right, which is in our case. Yeah, there can be many number of nodes, ignore that, there can be many number of nodes in between, but you just understand the concept. Okay, so now head moves here, and let's say head reaches first to D point. Okay, whenever head reaches H1, sorry, when head reaches D, that means H1 reaches D, what we'll do is we'll simply close this. That means like whenever it traverses D extra, that means H1 is here, H1 is nil. Whenever H1 is nil and H2 is not equals to nil, that means it's still not yet traversed the end. So we'll simply make H1, please make it like, look at this thing, we'll make simply H1 to point to this particular C. Okay, so now H1 will be at this position and H2 will be somewhere in between this position. So now let's say now H2 reaches the end at this position, that means H2 will become nil, and let's say H1 is not yet still fully traversed, that means it didn't reach nil. That means what we can do, we can simply point our H2 to our A. So we can simply start H2 from here again. So like that we need to traverse, and at some point, yeah, they will meet. At some point H2 will become H1. I'll tell you how, like this is also amazed me, but I'll tell you how H2 will become H1. But let's say H1 is nil and H2 is nil, then what does that mean? It's a straight line, right? If it's a straight line, you start H1 here, you start H2 here, and you're simply moving forward and you're reaching nil both at the same time, then that means it's just a straight line, there are no intersection points, you can simply return nil in this case. Okay, now let's understand this thing. See, let's say let me change the color, let me use green here. So now if you see it, let's say this is particular thing, this is A, this is B, this is C, and this is D. Okay, so let's say we traverse A to B and A to D, which is the distance is AB plus BD. So we are simply moving this particular, whenever it reaches this end, we are moving it to C again, right? Again it will reach at, like the meeting point is B, right? So to reach B, how much distance it is traveling? AB plus BD and CB, right? Plus CB. Okay, so now let's see the path of this, the pointer which is starting at C. Now it will travel CB plus BD, and when it reaches this point, we'll point to again here, which is A. The distance it needs to travel is AB, which is AB. So aren't these equal? Yes, right? AB cancels with AB, BD cancels with BD, CB cancels with CB. So that means the distance traveled by a pointer which starts at A, which starts at C, are equal when they are going to intersect at a particular point, or else they won't meet. or else it's a straight line, right? It's a straight line. Now by using this algo, we can simply say that the space complexity is reduced to order of 1. Time complexity stays the same. In this way you can solve this problem. I hope you got this thing. Yeah, this is a new algo for me also. Like, I was also not aware we can solve in this way. I only solve this way. Let's jump into our coding session. So let's see how we can code this thing. So we have discussed two approaches, right? One is a memory approach, or one is using a different algo. So let's see the memory approach. So we can simply make set 1 and set 2, which are maps, and these are boolean. And see, whenever the head 1 is equals to nil and head 2 equals to nil, you loop until these both are not nil at the same time. And now we can simply mark it as true, and we need to check whether this particular head 2 is present in set 1 or not. That's it. That's what we discussed, right? So we can make two conditions here. If we found it, then we can simply return the heads, or else, like, let's say head 2 has completed its list. So that means the head 2 is small, the head 2 is large, the head 1 is larger. So that means head 2 got nil, and we have to loop only head 1. So we will loop all the head 1 by checking only in head 2 and head 2 respectively. So by this, by the end, either we'll find a common junction point, or they are just a straight line. So from, if it's a straight line, then we'll simply return nil. That's it, right? So now let's see how we are going with a different algo. So this is a y intersection algo. So I'll simply keep a head pointer 1 and head pointer 2, and we'll loop until both are not nil at the same time. So they can be nil at different points, but they can't be nil at the same point. So now if head 1 pointer is nil and head 2 pointer is not nil, then that means we need to reset this pointer to head 2. And in the same way, we need to reset the head 2 pointer to head 1. And if head 1 equals to head 2, then that means that's the junction point, right? That is head 1 pointer. And simply we can increment the head 1 pointer next and head 2 pointer dot next. And if you haven't found anything, then that means it's just a straight line. You can return nil. I hope you got this problem. Like, if you have any doubts, you can put it in comment section. I'll be replying there. Hope you like my videos. Make sure to like and subscribe. So let's meet in the next lecture.